Hello everyone, welcome back to the channel. And today we are going to solve assign elements to group with constraint. Okay, so here we are given a group of numbers and a list of elements. What we have to do? We have to assign each group an element from this list of elements such that the element should be divisible of that group number. Let's say in the given list we have 8, 4, 3, 2, 4. An element as 4, 2. The index of the element which we are going to assign to any of the group number should be as minimum as possible if it is a divisible of that particular number. So these are our group numbers and these are our elements. Okay. So we have to assign element from this list to this group with the minimum index through which it is divisible through that particular element. So each group number, let's say if we are finding the divisible number from elements for 8. So what are the divisors of 8? So 8 has 1, 2, 4, and 8 as their divisors. Among all of these divisors, what are the elements? What are the divisors which are present in these elements? So we have 2 and 4 as the divisors which are present in this element. But remember, we also have to minimize the index. So these are index which should be minimum when we are assigning it to a group. Okay, so we have 2 and 4 as the divisors of 8. Among these two, we have 0 as a minimum index of 4. So we will be assigning 0, right? So let's say we have 0 and 1 index of these elements. But for 4, so 4 has 1, 2, 4 as divisors. Among all of these, which divisors are present in these elements? So we have 2 and 4 again. But the minimum index is 0 among all these two events. So we will be assigning 0 here as well. What about 3? So 3 has 1, 3 as a divisors. Do we have any of these divisors in these elements? No. So we would be simply assigning -1 here as the stated in the problem. But for 2, so 2 has 1 and 2 as a divisors. Among this, only 2 is present in the elements. So we would be assigning index 1 here. What for 4? So see, here we can reuse our previous calculation when we have already found the minimum index of the element, which was divisor of this 4. So we can store in some cache that for group 4, we have 0 as a minimum index so that we don't have to go through all the divisors and find out the minimum value of the index of the divisor element for this particular group. So we can reuse this and put it here. Let's consider a second example. So we have such, let's say we have a group which is 2, 3, 5, and 7, and we have elements as 5, 3, and 3. So let's give the index number here. So 0, 1, 2. Here, consider, let's say if we have 9 as a group number, then this has 1 and 3 as divisors. Which of these two index we are going to assign for this 3 divisor to 9 group? We are obviously going to assign 1 because it's a minimum index. So we don't require this as an element. So let's say if we are initializing one cache which finds the index of particular element, because we are not going to iterate through all the elements if we just want to find the index of particular element. So we will store, let's say in one hash map is present at, here we will give element and we will define it as an index. So if we have one element already in this is present at, then we are not again assigning 2 as a bigger index to this particular hash maps key. So Let's move on to the problem. So we will be having, so from this, we came to know that we will be requiring is present at hashmap and the one which we saw previously, that cache, which in which we will give group number and it will give us the minimum index of element so that we don't have to count it again. So these are two hash maps which we will be requiring for this particular problem. Okay, so let's calculate for 2. So 2 has 1 and 2 as divisors. Among all of these, nothing is present there. So we will just assign -1 to it. What for 3? So 3 has 1 and 3. Among this, we have 1 as a minimum index, which is present as a divisor in element. So we will assigning 1 here. What for 5? So 5 has 1 and 5. Among this, 5 is present at 0, which is a minimum index already. So we will assign 0 there. What for 7? So for 7, we have 1 and 7. Nothing of this is present in this element index, elements list. So we will assign -1 to it. Okay. So from this one, we can solve the problem easily with using this two hash map. One, to find the index of the element which is present in the elements list. Second is if we have already calculated a minimum index for a particular group. Let's say if we have 5 again, then we will not just find all the divisors of 5, 1, 5, and all of that again, and then again finding which is the minimum index, that is 5, and put it here as 0. Instead of doing all this thing, we will just fetch the minimum index for this 5 from this cache hash map and put it here. Okay, so these are the two hash map which we will be requiring to reducing the computation which we have already done. Okay, so what are the ways to find out all the divisor of one particular element? So it's just a simple algorithm. Let's say if we want to find the divisor of 20, then we will go from 1 to square root of 20. That means it will be around 4 point something. So let's consider it as a 4 point something, but let's round it off as a ceiling value. So that would be 5. So let's go from 1 to ceiling value of square root of number. So let's go from 1 to 5 and see if we are finding any divisors of 20. How we can find the divisors? If we apply modulo operator to any of the number, let's say I, if we got it as a 0, then I would be divisor of 20. Similarly, the another divisor we can get would be 20 by I. So let's calculate 20 modulo 20 by I is equal to 0. Then again, we have this as a divisor. So we will be getting these two divisors from this I. So for number 20, we will be moving from 1 to ceiling of square root of 20. If this is I, 20 modulo I is equal to 0, then 20 would be divisor. We will be seeing if we are getting I is present in elements. If it's present, then we will find its index through is present at and assign it to a minimum index. And this we are going to assign to this particular group number. So among all the divisors, which can be I or 20 by I, we will be finding all the indexes if they are present in this elements list. Then we will be assigning it to minimum index from calculating minimum of this index of this particular element and minimum index. And then we are going to assign to this group number, right? So let's jump right into the coding part. Okay. So let's first initialize our two hash map. First is for is present at, which would be required, which we will require to find index of element. The next one is cache. This will be required to find already calculated minimum index of the group if we have any. Now let's just assign index to each element. For that, we have to visit the elements list for index element. In elements, we will enumerate that to get this index, and we will be just assigning to our hash map. So we will assign our index for that particular element key in our is present at index, is present at hash map. If element is already present in this is present at, then we don't have to assign it again, because let's say if we have 5, 3, 4, 3, 3, 3 as our elements list, and if we have assigned 5 as a 0 index, this would be our element and this would be our index. 4 as 1, 3 as 2. Here, this is our minimum index for this 3 element. If in the next iteration, if we again found 3, then we don't have to assign 3 here, because this would not be minimum index. So if we are encountering 3 again, which is already present in our is present at hash map, we should continue that other, instead of assigning it again. So let's do that. And now let's go through each group's number in our groups list. Okay, here we need to initialize our assigned array. This would be our resultant array, which will include our answers. That means minimum index for each group item. We all would be okay. So let's go through each of its divisors. For that, we will be starting our I pointer from range 1 to square root of group. This will return us a float value, but we want an integer here. So to get the ceiling value of this particular number, we are just converting into integer and adding +1 to it. So let's say for number 20, which is our group item, we will calculate its square root, which would be around 4.5, something like that. That integer will convert it into 4, and we would be doing 4 plus 1. So 5 would be our final answer for 20. So we will be going from 1 to 5, but not including 5. So we would be moving from 1 to 4, because 5 square would be 25, which is out of the scope of this particular group. So for finding divisors of all this 20, we will iterate from 1 to 4. So if from this we will get I and group divided by I, this will give us integer, this will give us float value. So we are here only requiring integer value, because this elements would be list of integer. So for each of this iteration, we will have I and group divided by I as divisors of group. So there we have to check if I group modulo I is equal to 0. That means I is a divisor of group. So if this is the case, again, if I is a divisor and I is present in, so in is present at, that means our elements hash map. This is present at hash map has all our elements. So if I is also present in our elements list, then we will find the index of I, that means the index of that particular element, and assign it to our minimum index. Let's initialize our minimum index here as size of elements. So this is the maximum index which we can assign. So this is not actually present in our elements index. So let's initialize mm, size of elements, which would be equal to length of elements, and size of groups, which would be equal to length of groups. So, okay, size of elements, this is here. So we are initializing our minimum index as size of elements. And as we have saw, the another divisors which we can get, that would be group divided by I. So if that is also a divisor and that is also present in our elements list, then we have to assign its index to our minimum indexed variable from is present at hash map, right? So let's say if we found our minimum index, then it wouldn't be size of elements. It would be lesser than this, right? So let's say we have 5 elements, then the index of any element would not be equal to 5 if we have already found this particular divisor of this particular group from these elements. Then if it is equal to size of elements, then we would assign -1. Otherwise, we would assign minimum index. And then we will just simply return assigned array. So this is the simple code. Let's run it. So as you can see, it's accepted. Let's finally run it and submit it. Here we missed one thing. If we have already calculated the minimum index for this group, if it is present in group, if it is present in cache, then we can just assign that particular index without going through all of this computation. So here we have to, if we have calculated particular minimum index for this group, then we will store it in our cache. Here we are just storing -1 if we didn't find any elements. Here we are storing minimum index. So let's run it again. Okay, so it's accepted. Let's calculate the time complexity of this particular solution. So this we will run it from size of elements. This we will run it for size of elements time. And this we would be running it for size of groups. Okay. And this for loop we will be running for square root of number. Here, the number can be anyone. Number can be anything, but this number would be present in this particular group. So let's say to find the proper time complexity, let's consider this as a maximum number in groups. So this is our cap for this particular for loop. This particular for loop can run maximum of this many times. So our final time complexity would be O of size of elements plus O of size of groups into square root of G, where G is equal is maximum in group. Our space complexity would be O of, let's say we are initializing our is present at hash map. This will this will have O of size of elements. So this would be O of size of elements because we are storing indices for each of the element here. And this cache would consist minimum index for each of the group. So size of groups here as well. So this is the space complexity. So our space complexity would be nothing here in between stored additionally. Yeah, this is also O of size of groups because we are assigning index, minimum index for each particular group. But this is considered as a part of the solution which we are returning, and it will not affect our overall space complexity as well. So our overall space complexity would be O of size of elements and O of size of groups from this particular two hash maps. So that's it for today, guys. Thanks for watching. Catch you guys in the next one. Peace.